Yeah, so I'm Seth Spielman. I am a professor at the University of Colorado for a bit longer. I recently joined Microsoft and will be sort of full-time there, directing kind of data science in some of the web properties. But what I wanted to talk about today is a very academic thing. And it's something that has been on my mind for a while, and it is the rise of what I think of as model-based data and the implications of model-based data for social science and policy. And so in this talk, I'm going to argue that data in the social sciences are undergoing a fundamental shift. Increasingly, the data used by social scientists are the output of models, as opposed to being rooted in direct observation of the social world. And I think this transition, has been unfolding for decades, but it's been accelerated recently by concerns about privacy, about the politicization of national statistical systems, and it's also been driven in part by survey non-response, that is, people don't answer the phone or use the mail anymore, or sort of complete surveys. I think that this change necessitates an epistemic shift for urban professionals, researchers, and policymakers. And so my plan in this talk is to sort of convince you, or try to convince you, that there's been this modelification of data, it's a terrible word, to demonstrate its impact on social scientific inference, and to talk about what it means for the future of urban analytics. And I've added this little asterisk to my abstract, because as I sort of went through this and developed these ideas, a couple of things sort of hit me. The first was that I have a really strong US bias in this talk. So a lot of these ideas are, I'll be talking about developments that are largely occurring in the US, but I think or hope that they're globally relevant. The second thing is that I use the word data really sort of like in a very hand-wavy way. And to me, or at least in this talk, data means sort of social and economic data that describes the characteristics of people. And the last thing I wanted to say before I dive in is that this is a kind of new idea, and it could be garbage. Like, I could be wrong, and I'm hoping that at the end of this talk, you maybe call me out or keep me honest, and that we can sort of figure out if this was just a hopefully interesting but maybe half-baked idea. So with that, I'm going to dive in. Before we get into the body of the talk, I realize that the title of my talk includes two words that are both really sort of loaded. One is data and one is model. And both the words data and model mean different things to different people. And so I just want to pin down some definitions before we dive in. I think data, has always been a model of reality. That is a kind of, when in that context, when I use the word model in that context, I mean a sort of simplified representation of reality. But when I talk about model-based data, I'm using the word model in a statistical sense, or a computational sense. That is, model-based data is data representing the real world that is the product of some statistical or computational apparatus. That is, data that is coming out of some kind of machine or some kind of math. And that is not rooted only or at all in direct observation. So to keep things a little clear, I'm going to try, but I may slip up. I'm going to try to use the phrase direct data to refer to data that is collected through observation. This is our traditional conceptualization of data, right? You stick a thermometer in something, or you go out into the world and you measure something. That's direct data. And I'll use the phrase model-based data to refer to information that is created in whole or in part by statistical or computational methods. So with those definitions out of the way, my goal is to try to convince you of three things today. The first is that there's a continuum between direct and model-based data. The second is that the data that's available to social scientists is increasingly of the model type. That is, there's been this sort of transition from direct data to model-based data in sort of social science and policy. And lastly, that this shift to model-based data poses real epistemic challenges for all of us, or the the things we want to accomplish, whether that is creating policy or teaching students or doing research or whatever it is. I think it's challenging. So with that, I'm going to dive in and go sort of like from zero to kind of full nerd right away. And this slide shows what are called allocation rates from something called the American Community Survey. The American Community Survey is the largest, it's sort of the primary source of demographic and economic data in the United States. It's used to allocate billions and billions of dollars. It's made by the US Census Bureau, our sort of national statistical organization. And allocation rates are so basically the way the American Community Survey works is it's a survey, people get a form either in the mail or over the internet, and they're asked to answer some questions, and people may not answer all of the questions. They may like fill in some of the survey, but not all of it. And so if they leave pieces of the survey blank, in many cases, the Census Bureau tries to fill in those blanks, right? And that process of filling in those blanks is done using statistical models that are called allocation models. You might have, sometimes that's called imputation. And what this slide is showing you is allocation rates for income data for 15 years. And so what we see is that in 2005, about 15% of the people who received this survey didn't answer some or all of the questions about income. And as we sort of track over time up to sort of the most recent iteration, the number of people who don't answer questions about income has doubled. So now about a third of the people who received the survey, and it's millions of people in the United States, about a third of them refuse to answer the questions about income. So what that means is that when we look at a map like this, which is a map of poverty in the United States, it means that some of the data is like, normal data as we think about it every day. It's data that has been collected from real people in the real world. But some of the data, and over time, an increasing portion of the data is actually data that's been created by a statistical model, right? So now a third of the data in this map comes from a statistical model. But when you look at this, you wouldn't really see that, right? Maps like this have been made for 60, 70 years, and the process by which they're made has changed, right? The amount of allocation that has happened is going up substantially. So we're seeing more and more model-based data in the stuff that we consume. So I think there's this continuum between direct data, that is data that's rooted in observation, and model-based data, that is data that is coming out of some sort of kind of statistical machine. And I think that a lot of the data we consume as social scientists or as urban planners or policymakers can be at different points in that continuum. So surveys, which are sort of the primary source of demographic and economic data, those can sort of be in multiple places. They can really look like direct data, a direct observation of the real world, or they can really look like model-based data, right? They can take some inputs and generate a new number. So an example of model-based data might be having some observed characteristics of a person and trying to estimate their gender. Whereas direct measurement of that would just ask somebody to report their gender. And so I think that there's been this change, this gradual shift sort of towards I don't do right and left very well, towards the right of this continuum. And I think this is really consequential, and I think that will start to become clear once we look at more examples. But in order to help you understand this progression, I wanted to do a sort of quick and very sort of hacky history of this progression in urban social science. So I think the kind of modern, one sec, let me just get a pointer here. I think that the sort of modern demographic urban data sort of has its beginnings in the 1890s. And at that time, Charles Booth and also a group of people in Chicago began to collect systematic measurements of urban social conditions. And this was very much of the direct flavor, right? This was people going out into the world, looking at things and collecting information. So here's an example. This is a map that was made by Hull House in Chicago in 1895. And it's like classic direct data, right? People went out into the world, and in this case, they made a map of people's race or ethnicity. And they did this at so this map shows a few blocks of Chicago, and the little colored strips are houses. And even within a house, there are multiple kinds of ethnicities. And so this really breaks down the data in great detail. And it is a very direct representation of something happening in the real world at a high level of detail. Here's another example, same deal, but just for income, right? So this is sort of family level income at sub-building resolution in 1890. In 1910, there was sort of the next big idea was to actually not publish people's incomes on a map for obvious reasons. And this guy named Walter Laidlaw came up with the idea in the United States of using statistical geographies. And these became what we know of as census tracts. And these statistical geographies essentially allowed Laidlaw to aggregate data about the census into these units so that you couldn't look at an individual's information, but you could still get area level information. And this is what these maps look like. Walter Laidlaw was a Presbyterian minister. He directed the New York Federation of Churches. And so he sort of made this data on his own, and these maps were published by the Federation of Churches. But these really were the sort of first census tract maps in the United States. And this particular map is showing population density. Laidlaw is an interesting cat. He actually did a lot of this work himself. He like paid people to tabulate the data. This wasn't done officially by the US government, though later, once it became clear how useful these were, sort of publishing data in this way became the norm. And then two more quick stops before we enter model land. In 1940, rather than doing a direct measurement of everyone all the time, the census, our national statistical agency, started to use statistical sampling, and the use of sampling grew over time. In 1990, the US Census started to do something that they called swapping to protect the privacy of respondents. So in addition to aggregating data, they started to randomly move people around from place to place. So even though for generations, people used census data and thought of it as a direct reflection of the real world, there was this thing that happened in it where people were shuffled from one place to the other, or at least since 1990. They've been shuffled from one place to another, and nobody has any idea how much shuffling happened or how consequential that was. But it means that the data that we used and that we treated as a direct representation of reality, in fact, had this like sort of twist deep under the covers, and you couldn't really understand the impact of it. And then in 2010, we start to really enter the land of model-based data. And so in 2010, this thing which we just looked at called the American Community Survey comes into being. And in the American Community Survey, I think for the first time, you can start to see that the demographic and economic data that is available to scientists is actually not of the kind from 1890 Chicago. It is coming out of a model. And the way that you can sort of see this is the American Community Survey, because it's a very complicated model, like the documentation, the methods section for the American Community Survey is 212 pages long, right? So there's a book on methods. It's a very complicated model. And one of the things that they did is rather than just publishing a single realization of the model, they published 80. Now, one of those realizations was the official data, but then if you were nerdy enough and really like cared enough, you can go in and download these 80 different realizations from the model. And the way they created those 80 different realizations is they just sort of slightly perturb the initial conditions and run the model again, and then that gives you a different answer. So what we're looking at on this graph is, on the x-axis is the official estimate of the Hispanic population in every census tract in the United States, or not every, I sort of truncated the tail a bit, but each one of these dots is a little statistical area in the United States. The x-axis is the estimate of the Hispanic population, and the y-axis is how much variability we see in those 80 variations, those 80 different runs of the model. And so the dot, sorry, the little video thing is in the way, but the dot that we're seeing here, which is a bit of an outlier, but I picked just for the purposes of explaining things. So for this particular dot, the official estimate is that there are 1,000 Hispanic people in this neighborhood, but those replicates, those 80 different results have a range of 2,000. So the way that the Census Bureau tells people to sort of interpret this is that the official estimate is 1,000 people plus or minus 2,000 people. So that means there's somewhere between 0 and 3,000 Hispanic people living in that census tract. And in fact, that is the case where we have these very large variations from these different runs of the model in 15% of all census tracts. So in 15% of all census tracts in the United States, I would argue that if you look at the output from the model, the data about the Hispanic population becomes essentially useless, because you know it's somewhere from 0 to a lot. In 53% of all census tracts, the variation from the replicates is more than 50% of the estimate. So it would be 1,000 plus or minus 500, right? So there's that, looking at the variation from the model, looking at these 80 runs shows a lot of variation. Skip this. This is just sort of how the Census Bureau describes the model. And this fact that there's all of this variation in the runs of the model is true for all racial and ethnic groups. So this is a slide that I made with a friend we were working with the CDC on vaccine equity distribution, and they wanted to understand sort of equity in, they wanted to see how they were doing from an equity perspective for vaccines, but they were running into this problem where, say, they wanted to know how many Native Hawaiians or Pacific Islanders there were in a neighborhood. Well, here we're looking at a graph that is just like the one we looked at a second ago, where we have the official estimate on the x-axis, and on the y-axis we have the variability from the model. In all cases, in about 90% of all census tracts in the United States, estimates of how many Native Hawaiians or Pacific Islanders there are range from 0 to some number, right? That is, the variation from the model is greater than the estimate itself. For African Americans, that's true in 26% of all census tracts. For the Asian population, 37 or 38% of all census tracts. For the Native American population, that's true in about 80% of all census tracts. So there's all of this variability in the model. So it's hard, it's hard to think of the data as a direct representation of the real world, because there's so much uncertainty. And so we've asked people kind of what they do with this. We've done focus groups with urban planners around the country, and these are from some semi-structured interviews. These particular quotes are from a paper that's in the Journal of the American Planning Association. And planners say things like, well, in any good statistics class or software, a person who does statistics will, include a margin of error. That is, they'll communicate about the uncertainty from the model. However, we just don't use it. Nobody, unless you're a statistics type person presenting to statistics professors, where you have to have your footnotes in there, in the actual real world studies, nobody looks at the variability from the model. In another quote, this is a transportation planner in a sort of regional planning organization, says, talking about the variation in the estimates, that it makes them nervous about sharing information with the public. They don't know how to communicate the fact that the data isn't a direct representation of reality, that there is this uncertainty. If you start talking to people about it, this particular person says their eyes glaze over. I can't really see you. I hope your eyes haven't glazed over because I'm talking to you about it. But so he asks the question, or she asks the question, how do you present information in a way that's honest in terms of conveying the level of uncertainty that's associated with it? And I don't actually think we know the answer to that question. And this particular person's organization says sometimes they decide just not to share the information because they don't know how to communicate about the nature of the model. So I think we tend to think of data in sort of the social sciences and urban analytics as a representation of the world out there, not as one of many possible outputs from a model. However, once you can see the output from a model, I think it starts to lay bare some of the epistemological challenges of model-based data. And the stuff that I was just talking about for the ACS is only visible if you go and seek it out. However, once we get into the sort of the current moment, the 2020 decennial census, all of a sudden, the model-based nature, the model-based nature of the data is completely in your face. So this is a story, this is from my local paper, but it's an AP story that was on the wire. The headline was 2020 census full of unreliable data. People, homes vanished due to the 2020 census new privacy method. And so what has been done, and I'll just quickly read this quote. For Florida, the nation's third most populous state with more than 21 million residents, the 2020 census listed 15,000 neighborhood blocks as having a total of 200,000 residents, but no occupied homes. On the flip side, 1,200 of the state's about 500,000 blocks were listed as having occupied homes, but no population. So something like this, where we have people, but no homes for them to live in the data, or we have homes that are listed as occupied, but that have no residents in the data, really like throws in your face the fact that like the data that is coming out of these national statistical systems is not just a direct representation of reality, it's totally the output from a model. And in this case, it's the output from a model that is designed to protect people's privacy. People see this as a bug, but in fact, the Census Bureau sees this as a feature, the fact that there's this disconnect between population and housing, which most people think of, well, the data must be wrong. Right? You cannot have people living in a place, well, I mean, if they were homeless, but these are not people who are listed as homeless, right? They could be listed as, the census doesn't measure home ownership, but they could be like they have a home, but there is no home in the data for them to live. So there's this disconnect between the data and reality as most people would see it or experience it. So the reason the Census Bureau has produced the data in this way is because they're trying to protect privacy. And so the Census Bureau argues that there is, and I think they're right, that there's this fundamental trade-off between accuracy and privacy. So you could, for example, at one extreme, publish data which was 100% accurate and had no privacy. That is sort of like classic, like the most direct form of direct data you can think of. This is the data from Hull House from Chicago in 1895 that I showed you a minute ago that shows you people's income by house is exactly this, right? There is no privacy in the data, but it's probably pretty accurate, at least at the time it was collected. On the other hand, we could have data that had no accuracy, but completely protected people's privacy. That is, the data could be just complete noise. So the Census Bureau sort of manages this trade-off using something called a privacy loss budget. And so what the Census Bureau has done in the 2020 census is they've made a policy decision about where on this curve a particular data set should be. And what that looks like is this. So there's a complete enumeration of people that happens. And you sort of get the data back from this enumeration, and say in a particular city block, you knew that there were 25 people under 18 and 75 people over 18, and that the total population was 100 people. What the Census Bureau does is they apply a model called the Topdown algorithm. It's a differential privacy kind of framework. to these data, and they use that model to inject noise. And the amount of noise that gets injected into any particular estimate or any particular sort of row in a table is controlled by that privacy loss budget. So if you're willing to give up a lot of privacy for a particular statistic, you would inject a small amount of noise. If you really want that statistic to be private, you would inject a large amount of noise. But the end result is that you're sort of deliberately perturbing the data. And so in this case, we had 25 people under 18, 75 people over 18, a total population of 100, and then noise gets injected. The amount of noise is coming from a particular distribution, either a Laplace or a Gaussian distribution. And then you have this noisy data. So if you look at this noisy data, we can see that, okay, we still have 25 people under the age of 18, but now instead of having 100 people living in this block, we have 102 people in this block. So the noise injection has actually created people. There are some rules. There are some what they call invariant numbers. So for example, the total number of people in each state is invariant, meaning that the Census Bureau will inject noise, but at the state level, that noise sort of averages out to 0. The total number of housing units within each block is also invariant. That is, they won't destroy or create houses, but they will destroy or create people. And then the last kind of invariant thing in the 2020 census is what are called group quarters. So things like university dorms and prisons, things that house large numbers of people. And the Census Bureau sort of calls out in their documentation that for any given geography, particularly at the block level, the uncertainty introduced by the disclosure avoidance may result in apparent inconsistencies between population and housing unit tables. So that thing that that news story about there being unreliable data in the 2020 census is in fact as designed. But for people who think of data as a reflection of the real world, it's like deeply problematic. This is an article that was in Bloomberg in the sort of City Lab thing, and the reason there's a picture of this is Liberty Island, the island, this is like tiny little island in New York Harbor that holds the Statue of Liberty. And the sort of starting point for this article is that the census says there's 50 people living on this island, and anybody who's been there knows like nobody lives on the island, and those 50 people come from the disclosure avoidance methodology. This article interviewed Gary King, who's sort of a big shot Harvard statistician. And I think what Gary King said in the article is kind of interesting. So I'm just going to kind of read the quote. He said that if we just make believe that the data is accurate and ignore the measurement error, then we'll get the wrong answer. I don't know the consequence. So, and here he's referring to the swapping that happened up until the sort of modern era, that moving of people around. He says, I don't know the consequence of swapping in the data and not telling everybody, which is what the Census Bureau did for decades. It could be big, it could be small, King says. Since so many things are calculated from the census, so many quantities of interest to so many people, then it is almost certain that some of those calculations that have been done by thousands of academics and people in the public since 1990 were just wrong. We as a nation lived with that. We lived with those wrong calculations, because we had to balance the privacy of individuals with the good that goes to society. And the reason he's sort of making this point is that the differentially private algorithms that the Census Bureau is using in the 2020 data, while they create these sort of logical inconsistencies in the data, they do allow you to sort of see the distribution that is being used to perturb the data because the privacy loss budget is public. So the article goes on to say that differential privacy enables users to know how much noise has been introduced, a margin of error measured as confidence intervals. While the mechanism of differential privacy is complicated, the noise ultimately adds up to 0, which is actually not exactly true, especially if you're an urban professional. And I want to sort of pick that apart a little bit. So here we're looking at a demonstration data product that the Census Bureau published. So in 2019, before they sort of went live with this private sort of new approach to publishing data. They re-released the 2010 census, and they did that without the privacy methods applied as it was sort of originally published, and with the privacy methods applied. So that allowed you to look at the individual places that gained or lost population. In the 2020 census, you couldn't see this. You only get a single realization of the output from the model. There's nothing to compare it to. But in this demonstration data, you could look at the places that gained population and lost population. And the Bloomberg article is correct in that in all of these demonstration products, some places lost population and some places gained population, but they always averaged out to 0. So this graph is showing you total population, and you can see pretty clearly it's a nice uniform distribution that averages out to 0. This is showing you the Hispanic population, and again, it sort of nicely averages out to 0. But it's not necessarily true that because things average out to 0, that there isn't sort of bias in the data, local bias in the data set. So a balanced histogram can produce a sort of biased map. And this is something that I don't think the Census Bureau has a good handle on. So for example, it could be the case that all of the places that lose population are clustered on a map, right? So all of the places that lost population could be in the lighter colors on this map. This is supposed to be a map where, light colors mean you lost population, dark colors mean you gained population. On the other hand, the places that gain population could be clustered on a map. So we could have something that is unbiased at the national scale, but if you're a local planner who happens to be working in this place, or a scientist who happens to be studying this region, the data no longer sort of reflects what's on the ground. Or it could be the case that the noise injection is sort of spatially random, that it looks like static, and that in any particular place, some places gain and some places lose, but locally it averages out to 0, as opposed to only globally averaging out to 0. And what we in fact see in the differentially private data is that the places that gain population and the places that lose population are not randomly distributed in space; they're clustered in space. So the total population tends to be sort of like certain variables tend to be spread out in space, and others tend to be clustered in space. And this is because in places where we have sort of rare groups, we want to distribute them, and in other places where we have common groups, we sort of move them out in areas to sort of obscure rare groups. And so the exact dynamics are kind of complicated, but it's definitely not the case that the data, this algorithm is locally unbiased. So just sort of wrapping up on this point, occupied housing units in areas with no population highlights the epistemological challenge of model-based data, right? This idea that data is a reflection of reality completely falls apart when there are these logical inconsistencies in the data. And I think that what's happened in the 2020 census is in fact just the crescendo of this process that's been unfolding for a long period of time, of this movement towards model-based data, where the statistics, the data that we're working with they're not tied to the real world. They're outputs from some computational or statistical apparatus. I think policymakers, the public, and researchers tend to think of data as this direct representation of the real world, but it's not, right? It is more often, or increasingly often, output from a model, right? It's a realization of one of many possible outputs from the model. So one might argue that this doesn't matter, that it's just talking about census data and worrying about census data is really old-fashioned, that we have all of this other data out there in the world. We have basically unlimited data from social media, from logs of online services, from transactional things, payment transactions, other kinds of online transactions. So the shift to model-based data in public demographic data sets is inconsequential. And I would argue that that's not the case, that actually all of the big data, or much of the big data that's out there in the world, and I say this as somebody who has spent a large part of their life sort of building products or sort of interrogating big data sets, it's often devoid of meaningful socioeconomic attributes. And extracting sort of business or policy relevant insights from big data often requires understanding the people in the data. So I still believe that high quality representative demographic data sets are required to do a bunch of things, to prove that algorithms are unbiased, but also to do analyses of equity or inequality in the urban context. And for me, this became apparent, especially looking at things like some of the literature that came out around COVID. So here we look, this is an article from PNAS. There was like a cottage industry of these articles during the pandemic. People were just sort of spitting them out. But this article was in PNAS, which is sort of a top shelf journal. So I think it's useful as an example. So this particular article looks at social distancing responses to the COVID-19 declarations. And it looks at, in particular, how different income groups responded to the lockdown. And it does this using data from SafeGraph, from PlaceIQ, and Google. So these are all data sets that track the location of a device. But because you don't know the income, like there's no meaningful information about the nature of the person holding that device in the data set. So in order to understand income differences, what the authors of this article had to do is they had to append that log data to the census data. So they took this data and they sort of added the census data. And I'm not sure if they had the raw individual log data or if it came sort of pre-aggregated from these vendors. It wasn't clear to me in the article. But in either case, what their argument is that high income people or people who lived in high income areas were able to sort of stay home and reduce travel much more than people who lived in low income areas. So this is an example of why, even in a world of largely unlimited data, you still need these high quality demographic and economic data sets. I'm going to skip this. I've done some work sort of related to this on Microsoft, and I think that analyses like this are sort of deeply problematic because of the ecological fallacy. That is, the idea that the characteristics of an area applied to a person is something that we've known is a kind of logical fallacy since the 1950s. But because we don't have good alternatives, we still do it. And we did a similar kind of analysis looking at fairness in AI at Microsoft. And one of the things that we were sort of privileged to do is we could do that same kind of area level analysis, and we see sort of differences in how services perform based upon the demographic characteristics of areas. But for 10 to 20% of our users, we have demographic information that they've sort of opted into sharing with us. And when we look at those 10 to 20% of users, the relationships that you see when you do that, when you sort of append area level characteristics to an individual, don't hold. They sort of flip. You can sort of see the ecological fallacy. So point being that we need demographic data sets to use big data, but that it's sort of fraught, right? It's problematic. So I think that there's another sort of so what kind of moment where the fact that many national large-scale demographic data sets have moved from this direct enumeration more towards this model-based paradigm. There's a question of like so what? Like if it doesn't matter to the outcomes of decisions, like if the data still looks the same and behaves the same and is still a reasonable reflection of reality, like who cares? So we've done some experiments to look at how model-based data affect the outcome of data-related tasks. And in particular, we did a study of 55 urban planners in Portland. And we asked all of them to complete the same task, which was to identify the poorest part of a city. And by poorest part, it was sort of 5 contiguous census tracts. And we showed them a map of Portland, which was a city. All of these people were planners in Portland. We did this with Portland State University, which was a local university. We showed them a map of Portland, and we asked them to do this task. But we also showed them a map of disguised Portland. So disguised Portland has the exact same data in the exact same spatial arrangement, but I've sort of like redrew the census tract. So it shouldn't be recognizable as Portland. And then we showed them the variability from the replicates of the ACS, the variability from those 80 different runs of a model. on the map. So each person was exposed to 4 experimental conditions: a map of Portland, a map of disguised Portland, and then a Portland plus a visualization of uncertainty from the model, and disguised Portland plus a visualization from uncertainty. Each person completed all 4 tasks. That is, they had to find the poorest part of the city on all 4 maps, but the order in which they did those tasks was randomized. And so this is the map of disguised Portland, and this is the map of Portland. And if you look carefully, it's sort of directly apparent when you look at these things side by side, which people didn't do. They saw these one at a time. That really what I've done is to make disguised Portland, I sort of flipped the map around and edited the census tracts and tried to remove the river. But these are the same data in the same sort of topological arrangement, but moved around. So in a perfect world, your sort of naive expectation would be that people would choose the same area on both of these maps as the poorest part of the city because the data is the same. And then we visualized uncertainty from the model in 2 different ways. We didn't notice a lot of difference between these experimental conditions. We showed uncertainty using this sort of squiggly line paradigm. The cartographer I was working with was into this idea, so we did it. So sort of squiggly lines to show uncertainty, and then we also did it with this sort of more traditional stoplight representation of uncertainty, where things were green, yellow, or red, depending upon the amount of uncertainty in the estimates. And so then we looked at how different people's selections were when across different kinds of map pairs. So P stands for Portland, and P plus U stands for Portland plus uncertainty. So when we showed people so on average, about 13% of respondents, of people in the study, changed the area that they selected as the poorest when the map condition changed between Portland and Portland plus uncertainty. When we look at disguised Portland, that number went up to about 30%. So I think what we're seeing here is that local knowledge sort of mutes the effect of uncertainty from these model-based forms of data. That is, people can handle it when they understand the place well. When we look at, I'm not sure what happened, when we look at disguised Portland versus Portland, there was a substantial amount of change, even though the data was the same. And when we look at the sort of the full force of the model, when people are forced to fully engage with the uncertain nature of model-based data, both in terms of Portland and disguised Portland. So we're showing them the same data, but with a representation of uncertainty. In that case, 40% of people changed their selection. So when forced to sort of fully engage with a model, with the model-based nature of the data, you get really different outcomes from professionals who are used to looking at this data all the time. And I think that's surprising and a sort of important thing to know about model-based data. Okay, so with that, just to sort of wrap up, I have tried to convince you that the general population, well, I haven't tried to convince you of this. I think this is true, and if you disagree with me, feel free to yell at me in 2 minutes. I think the general population of urban planners, the public, researchers, still think of data as a direct representation of the real world. That is, we think of data as it appeared first in 1895, right? We think of it like this map on the right here, that it's sort of where the data represents the world out there. I think the 2020 census sort of directly exposes this idea as problematic because the model produces results that could not exist in the real world. But in a less extreme case, we're still dealing with that same kind of phenomenon. It's just less in your face prior to the 2020 census. So I think model-based data challenges traditional conceptualizations of data as a reflection of the world out there. And I think talking about this and sort of saying this to people can be totally paralytic. That is, it's not clear what to do when you recognize that this is the case. It's like the so what, the how to sort of interact with the data in a way that is more appropriate can be difficult to figure out. It's unclear how to responsibly engage in meaningful data-informed policy or research when you sort of recognize the fact that there's all of this variability or that the data is just one output of many possible outputs from the model. I think there just aren't good alternative data. That is, we're often stuck using these data sets in the United States, even though they have these undesirable characteristics, and there aren't good conceptual frameworks or technical tools for dealing with these data. So we're stuck in the status quo in spite of these profound changes in the data. So what does this mean for urban analytics? And sort of what does this mean for the future of urban analytics as a practice or as a discipline? I think that model-based data makes it clear that translation and training are critical tasks. That is, planners and policymakers and scientists need to figure out how to communicate with model-based data to the public. That is, if we want to use data to drive changes in the world, we need to be able to communicate with it in a way that is responsible and effective. I think there's actually a similar kind of problem that comes up when we're dealing with just models, not model-based data. That is, how do you sort of fully represent the uncertainty in a model without sort of confusing people? And there's a lot of sort of literature on this in the climate communications world, but I think it also affects us as social scientists using these new forms of data. I think that demographic data is foundational for science and local governments, but we're often passive consumers. I think that institutions like Turing can take an active role in articulating a compelling vision for national statistical systems that balance privacy and accuracy, but that also sort of makes sense to real users. I think that these large-scale demographic and economic data sets are essential for addressing equity, for doing any kind of urban analysis. We need them, but I think we need to figure out how to use them well, given that they're often output from a model. I think that, if we think about, I think, there's a lot of literature in the urban world and in geography and in sort of data science generally about artificial intelligence. And I think that if we want to understand fairness in large-scale AI systems, you need to have representative data sets about the entire population, not just people in your training and test set. And I think a real understanding of how models perform in the real world, who they benefit or don't benefit, sort of require these data sets. And I think for cities to sort of realize some of the efficiencies that these kinds of models offer, it's really important that they demonstrate that those outcomes are fair or just. And so again, these data sets matter a lot, even though they're sort of old-fashioned. And so with that, I will end and thank you, and sort of curious if this notion of model-based data is kind of hogwash or not. But thanks for your time.
Cool. Well, thanks very much, Seth. I'm gonna try to find a spot where you can see me and everyone else can see you rather than me. And we do have time plenty for questions, both on site and online. So if you're listening to these over the interwebs, please feel free to use the Q&A functionality on Hopin, and if you're here, you can either use the Q&A functionality on Hopin or the hand functionality on your body, and a microphone will appear where you can pose your question. So we have one from Rachel Franklin on the audience. Go ahead.
Thanks, Seth. This was great. I don't really have a question about the right-hand side of your timeline. I think this is great. I agree with pretty much everything you said. I'm really curious, though, about the left-hand side of the timeline and the extent to which you think we ever really were getting a direct observation of the data. I mean, you could make an argument that this continuum is a little bit like now we have computers synthesizing data, but we had humans synthesizing data 100 years ago, 200 years ago. So I just wonder if you could unpack that bit a little bit, especially the idea of people going out and observing in the real world what they think is going on. There's a lot happening there that is synthesizing the true but unknown and putting it on the page.
I agree with you. I mean, I think that's part of what I was trying to say, that it has been a continuum. I think a couple of things have changed, though. One is that people just don't respond to surveys anymore. So the number of people who the American Community Survey, which is sort of the bread and butter demographic data set for the United States, for a long time, about 60 to 70% of the people who received the survey answered it. Now that number is down around 50%. In the 2020 decennial census, while the sort of overall response rate was about the same as a decade ago, the number of people who didn't answer questions about race and ethnicity just went through the roof, because for a bunch of reasons, mostly around probably being afraid of the government sort of using it against them. And so I do think there have been these changes in the real world, and that people don't answer these things anymore. And that makes data more model-based than it was in the past. And I think the literature on differential privacy, and that's sort of the invention of differential privacy in 2006, sort of changes the potential for data. It does create the possibility for publishing data that is in some ways more detailed, but also like less tethered to reality. So you can publish these differentially private data sets that have individual level information in them, but don't actually reflect any individuals. And so I agree with you. I do think there's a sort of future world in which we are dealing more and more with these things. And I think you're right that in the past we were still dealing with them, but I think it was less of a problem because people actually answered questions when you asked them.
Cool, super. We have one in the back. I think Alex was first, and then we have Alistair.
Hi, Seth. Great talk as usual. I suppose it's a reflection, really, and I think this applies to all types of uncertainty in the way that these surveys are used geographically. As uncertainty increases, that essentially constrains where we can actually make evidence-based policies decisions with some degree of effectiveness. Essentially, we're more likely to get it right in locations where we're more certain about the estimates that we're basing those on. And I don't think that's changed in the sort of new way and old way in which these surveys were disseminated. And I suppose it's probably more a reflection than a question. But I suppose it also speaks to the role of how we actually use those data to inform policy, and whether, so it looks like I've got my arm around Tao Cheng there. Very sorry, Tao, I'll just move it over this way. Different row. So my point is, I think I'm almost arguing the case for, policy actually works at, much more aggregate scales. We don't necessarily apply policy at the level of the neighbourhood. And I think I'm actually probably arguing for more qualitative interventions in the use and development of sort of evidence-based policy where these kind of data are applied. And I suppose it's do you agree with that? You did speak a little bit to this idea of how local policymakers and local knowledge is important, but I think that actually could be increasingly important with the way in which these data are kind of disseminated now.
Yeah, I sort of agree with you, and I sort of don't. Like I think that at least in the U.S. context, lots and lots of data, lots and lots of money is given out to places based upon this uncertain neighborhood data, and so the policy regimes and the legal regimes do not reflect the fact that these data are coming from a model and are highly uncertain. So, for example, there are programs that are run by the Treasury Department which say that if a place is 51% poor, you qualify for the data. You qualify for a grant. But if you're 49% poor, plus, and a different run of the model says you're 55% poor, you don't qualify. Like, it's just the one run of the model that has been blessed as the official one, not the sort of full spread of the model. And the reason that's the case is because largely sort of policy inertia, but even if you did want to change the policy, in a lot of cases, the spread from the model is so big that you lose the ability to sort of differentiate among places, right? That is, all places would qualify for the grant. All places would be 51% poor in one run of a model, right? And so, or could be 51%. Like, if you sort of hit the button enough times, any place could qualify. And so I do think that there are real policy questions, at least in terms of how you distribute, use data to distribute money, which is, sort of where the rubber hits the road for government, if that makes sense.
Yeah.
Yeah.
Cool. So before we jump on the question, I think privilege of the boss, Mark had a follow-up question on that.
Thanks. Yeah, I did want to comment on that point. Mark Birkin, University of Leeds. I mean, I can debate further with Alex later because he's here and you're not. But there's an assertion in there about the relationship between the uncertainty and the robustness of the policy response. And my general feeling was, I'm just not convinced that we know enough, that we have enough certainty about those kind of assertions. I mean, one of my reactions to the talk, and I was one of the people who I glad you came to the so what type question because I was thinking about that before you got there. But one of the things that struck me was, I'm just not. I think we've been blinkered somewhat by the whole kind of mathematical and statistical apparatus. I was interested that you're talking in the first part of the talk about classical kind of statistics and confidence intervals and that kind of thing. So it's just my gut feeling. I mean, the other thing is I'm not sure I was wholly convinced at this stage about the kind of the demonstration in the later part of the talk about the way that we address this or demonstrate it. So I guess one of my conclusions ultimately was one thing that we almost certainly need is some kind of new way of thinking, a different kind of mathematical and statistical apparatus that goes beyond the kind of the confidence intervals and the classic kind of stuff, and that is more rooted in those questions about does it matter or doesn't it, and for what purpose? It may actually, okay, I won't go further than that. But I mean, I just wondered if you could say a little bit more about whether you agree with that and whether you think particularly kind of the AI data science kind of way of thinking potentially has something to contribute about different ways of looking at data, particularly in relation to these these kind of policy and practical sorts of questions.
Yeah. So I actually agree with you. Like that asterisk in the beginning, like at a certain point in sort of pulling this together, which is a talk that I haven't really given before, I thought like, well, this is like kind of garbage. Like there's always been uncertainty in data. There's always been confidence intervals. This is not anything new. But I actually think that it may be new. And so I think that to some extent, what we're seeing is those innovations in data science coming to bear on national statistical systems, or at least trying to. And I think and I do think this creates kind of epistemic challenges. And one of the reasons I think that it does is I think that computer scientists and statisticians and those types of people will look at a data set and say, well, it's unbiased, right? The errors add up to zero. The histogram is nice and pretty and balanced. But one of the things that I think is different between that community and say geographers or demographers or planners or people who work in policy is we don't only care about the whole. We don't only care about the properties of the aggregate. We care about the variability, say within a country or within a state or within a city. And it's entirely possible to sort of preserve those higher level, those say, city level properties, but to sort of break the pattern within the city, or those state level properties, but to break the pattern within the state. And so I think that in particular is a challenge. I think that data scientists still, it's a very data-driven enterprise, right? And so, in AI, I think the typical model is if you're working in a sort of building a large scale AI system, you have the classical model that's used now is something called human in the loop machine learning, where you sort of have an initial model, you run it, you get output, you have people label that output, and you use that labeled output to retrain the model. And so what ends up happening in those kinds of settings is you end up optimizing the system for your current users or certain kinds of behaviors among your current users. And where I think these large scale demographic data sets can be helpful is they can help you understand how your system performs relative to the real world out there, not just to your users, but that becomes challenging when the model maybe doesn't reflect it. So I'm not sure I answered your question well. That feels like I kind of rambled a bit, but